Okay, so first thing we need to do to solve using Gaussian elimination is to put this system into a matrix. How do I do that?
Big bracket.
Big bracket, okay. 1. Good. Then. Good. Then. And. Perfect. There is our matrix. What is good about this matrix? It has a 1 in the top left-hand corner. Perfect. So, what is the first thing I need to do then?
Figure out the body.
I need to make that 2 into a 0. How can I do that?
Subtract by 2.
So, can I just subtract this whole thing minus 2? The whole row 2 minus 2?
Yes.
No.
What do you have to do? Whenever you're adding or subtracting
Subtract by
another row, you have to add or subtract by another row. Good. Now, yes, in this case it may work out, but for future practice, you should always subtract or add by another row. So, I'm going to do row 2 minus what? 2 times row 1. Perfect. So, my row 1 is staying exactly the same. What is 2 minus 2 times 1? 0. What we wanted to get. Perfect. What is 3 minus 2 times 1? What is 33 minus 2 times row 1? Oh my gosh. What just happened for us? I got 2 things I wanted, right? I got a 0 as the x value in R2, and what else did I get? A 1 as the y value. So what do I already have? The 1's on my diagonal. So what's the only last thing I need to do? I need to get that 1 above the R2 one to be a 0. How do I do that? I just do row 1 minus row 2. So my row 2 stays exactly the same. What is 1 minus 0? 1. What I needed it to stay a 1, right? That's why we would not multiply this whole top row times 0. Because then everything would be a 0, getting rid of that 1 that I really, really need. And then what is 1 minus 1? 0. And what is 12 minus 9? So what does this mean? Perfect. I'm done. X is 3 and y is 9. I have the 1's on the diagonal. And I have a 0 above and a 0 below. So this is my answer. This one was a heck of a lot easier than your homework problem, right?
Yes. Yeah.
Yes. The reason, so any more questions on this? Okay.